continue. Okay. Hey there, science enthusiasts. Today we're tackling the 2023 November paper 1 physical science. Okay. Get ready for some mind-bending physics and some exciting solutions. Okay. So basically today, guys, we're gonna be focusing on the physical science question. Right. It's the November 2023 paper 1. Okay. So let's get into the question. Right. Let's get into the question, guys. Let's get into the question. Right. So the first question says. It asks us to what, which is what we're gonna first do question 2.1. Right. So what does the question require of us to do? It says state Newton's second law of motion in words. Right. So we know Newton's second law is derived from the what, from the Newton's formula that says F net is equals to ma. Right. So for us to describe this formula in words, it says that if the resultant force, right, so if the resultant force, right, if the resultant force acts on the object, acts on the object, right, it says that the object will accelerate in the direction of the resultant force. The object will what? Will accelerate, right? The object will accelerate in the direction of the resultant force, right? Sorry about that. The direction of the what? Of the resultant force, right? It says that the acceleration is directly proportional. The acceleration is directly proportional to the resultant force is directly proportional to the resultant force and inversely proportional is directly proportional to the resultant force and inversely proportional to the what? To the mass of the object. To the mass of the object is to the mass of the object. So what this means, guys, is that if you push an object or you apply a force to an object, that object will what? Which will move or accelerate to the direction of the resultant force, right? And also the acceleration of that object is directly proportional to the resultant force, meaning that as you apply more force, the more the object will accelerate, right? And the acceleration is directly proportional to the what? The acceleration is directly proportional to the resultant force. So meaning that the more force you apply, the more acceleration the object will have, right? And it says that the acceleration is what? Is inversely proportional to the what? It's inversely proportional to the mass of the object, right? So the bigger the mass you have, the lesser the object will accelerate, meaning that you have to apply more force to the object if you want it to accelerate more, right? So if the object with smaller masses will actually accelerate much further, or actually accelerate much more compared to the object with bigger mass of the same applied force. So that's what does this mean. So let's go to 2.2, right? So understand physical science is not a very easy subject, it's an applied mathematical subject, meaning that you need to use logic when you're tackling your questions, right? So basically the second question says that draw the free level body diagram showing all the forces acting on object A, right? So basically what you do is that we represent object A with a dot, right? So this is object A. So which forces are acting on object A? So the first force that is acting on object A is what? Is the gravitational force, right? So you represent by drawing an arrow downwards, right? So the second force that is acting on object A, it's what? It's the normal force, which equates the gravitational force, right? Also the third forces that are acting on the object is the frictional force, right? So we can apply this force at an angle, because we see that our question in the 2023 November, we have an object that are acting that are being pulled on a plane, right? Meaning that it's a horizontal plane, guys. So this is FG, gravitational force. It's gravitational force. right? And then this is what? This is a normal force, guys. Right. So the third force is the what? Is the applied force. Let me just redo this question because I don't seem to have space and enough space to do it. So let's do 2.2 here. Let me go further. So this is 2. So as I've said, you represent object A with a dot, and then the first force that is acting on object A is the normal force. So I'm gonna write this as what? A normal force. Right. And then we have the gravitational force that is acting on the object. Guys, please bear with my handwriting. I'm not using a ruler, so my drawing won't be to scale. Right. So this is what? This is a gravitational force, Fg. Fg, which is what? Gravitational force. Right. And then third force that is acting on the object is what? It's these two forces. Right. So the first force is what? It's the what? It's gonna be the frictional force. And then the third force is the what? Is the applied force, guys. This is the what? This is the applied force. This is FA, which is what? F applied force. This is applied force, right? So basically we have what? We have three forces that are being represented in this diagram, right? We have what? We have the gravitational force, right? And then we have what? You have the gravitational force. We have the frictional force that is acting on the object in a plane, in an angle. And then we have what? We have the applied force, which is the what? The force that is pulling the object up in the air, right? And then we have the normal force. We know the normal force is the force that equates the force of gravity. The reason why we don't sink, right? So yeah, let's do 2.3, guys. Let's do 2.3. Right. So question 2.3 says 2.3.1. So guys, the first important thing that you do in this type of questions is what? Is to first choose the what? You first choose the direction of motion, right? So in this case, we're gonna choose what? The upward motion is the direction, as what? The positive direction of motion, right? So it's a upward is the what? Is the positive direction of motion. So you're telling your marker that the upward motion is gonna be the what? The positive motion. So anything that is going down is gonna be negative, guys. Okay. So yeah, that's the first thing you do. Right. So 2.3.1 says calculate the magnitude of the tension in the string. Right. So now since we're gonna calculate the magnitude of the tension in the string, right? So basically how you can tackle these questions, guys, is that you do not have to look at the whole diagram or the two bodies, which is the block A, which is why you don't have to look at block A and block B at the same time, right? So what you do for yourself is that simply you look at specific at one object, right? So in this case, I'm gonna choose what? I'm gonna choose object A, right? You look at one specific object and you only solve for it, because if you look at both objects and try to solve them at the same time, these questions are gonna be tricky for you, and then you're gonna get dizzy because you won't be able to solve these two objects simultaneously. So look at the specific object and then you solve for its forces, right? So basically we're gonna look at what? We're gonna look at object A, right? So we take what? Object A. Right. So the first thing you do when you're solving for object A, right, is to the first thing that you do, don't make a mistake, is to solve for what? Is to solve for the what? For the frictional force, right? Not for the frictional force, is to solve for the gravitational force, right? So you don't solve for any gravitational force, guys. You solve for the gravitational force that is parallel to the plane, right? So basically this is the plane, right? And then this is the gravitational force. And let me change the pen. This is gonna be the gravitational force that is gonna be parallel to the plane, right? Which is, we call this FG parallel, right? So it's very important, guys, that you practice your grade 11 physical science, because this all ties together, right? this all ties together. The mechanics that you did in grade 11 and the mechanics that is in grade 12 it's the same thing basically, right? Because the physical science or mechanics that you do in grade 12 is the applied one that you did in grade 11. So it's important that for you to understand mechanics and Newton's laws from grade 11, right? So basically what it says that is that for you to be able to tackle this question, we're gonna do focus at what? At FG parallel. So this is FG parallel, right? So what does the formula for FG parallel says? It says that it's what? It's mg sine theta. It says mg sine theta, right? So we know that the mass of the object is what? We know that the mass of an object is 4, guys, because m stands for what? For the mass of the object, and the g stands for what? The g stands for the gravitational force, right? So it's gonna be 9,81, guys, right? And then it's gonna be sine, and then the angle that you're looking at, we're given that the angle that these objects are being pulled at is what? Is 35 degrees, right? So it's gonna be 35 degrees, right? So it's gonna equal to it's gonna be, so 4 times 9,8 is gonna be what? It's gonna be 39 comma what? Well, let me bring a calculator. So basically you're gonna say 4 multiplied by what? By 9,81, and then you have what? You have your answer is 39 comma what? 39,24. 39 comma what? Comma 24, right? Sine 35 degrees, right? So it's gonna be this answer, which is gonna be multiplied by what? By, it's gonna be okay, answer multiplied by sine 35 degrees, right? Which is gonna be what? 22,507. 22,507, which is gonna be what? 22,507 newtons, right? This is the first step that you do. So we are done with the what? We're done with the gravitational force that is parallel to the plane, right? So now all you do is that you need to apply the what? You need to apply the Newton's second law formula. It says F net is equals to what? Ma, right? So when you're looking at what? When you're looking at this a specific object A, we know that object A has what? There are 3 forces that are acting on object A, right? We know that there's a what? There's an applied force that is acting on object A, right? So it's applied force, and then it's the what? Is the frictional force 1, right? So it's applied force. It's what? It's F applied, right? And then it's the frictional force, right? And then the what? Is the FG parallel, right? And all these what? Okay. And all these what? Frictional force, on all the frictional force and the what? FG parallel, they are acting against the what? They are acting against the applied force basically, right? So let's go get into it. So our answer is gonna be what, guys? So you need to understand these topics basically, because if you do not understand the whole content, you won't be able to tackle the question, because you cannot create maths or physics. The questions that I'm doing are not the questions that are gonna come up in the final 2024 exam paper. So you need to understand the content basically, right? So it's gonna be the what? Is F applied minus what? Minus the frictional force minus what? Minus the what? The FG parallel, right? Which is equals to what? Which is equals to Ma, right? So the applied force now in this case, since we're looking at what? Since we're looking at the object A, now we're looking at what? We're looking at object A, right? So the applied force for object A is gonna be the what? It's gonna be the tension. It's gonna be the tension that is being. It's gonna be the tension in the string basically. It's gonna be this what? It's gonna be this tension, guys. It's gonna be this tension, right? Because there's no applied force in object A. It's only object A is being pulled by object B. You understand? So it's gonna be what? It's gonna be the tensional force. It's gonna be the tensional force minus what? Minus friction minus FG parallel, which is equals to Ma, guys, right? So basically now it's gonna be the what? It's gonna be the tensional force minus what? Minus friction. We are told that frictional force is equals to what? 5,88 newtons. So you apply what? You put brackets. It's 5,88 newtons minus what? So the FG parallel that you have calculated, it's what? It's 22,507, right? Which is equals to what? Which is equals to Ma, right? And then it's gonna be T minus what? Minus 5,5,88 minus 22,507 is equals to what? Is equals to the mass of the object is what? It's 4 kg. It's 4 kg. And then the acceleration of the object is what? Right. And then we were told that these two objects are what? They're accelerating uniformly at what? They're accelerating uniformly at 2 meters per second. Right. So if the object B is accelerating at 2 meters per second, which means the same acceleration that is being applied on object B, the same is the same what? It's the same acceleration that is being applied on object A, guys. Right. So these are very simple questions. All you need to do is to understand the content. Do not cram maths or physics because it's not a context-based subject, it's a logical subject. So it's gonna be what? It's gonna be 2. We put 2 here. You put 2 here. Right. So it's gonna be what? It's gonna be minus 5,8 minus 22,507, which is gonna be what? It's gonna be t minus what? It's gonna be t minus 28, t minus 28 comma what? 28 comma 387. Okay, which is equals to what? Which is equals to 8. Okay, so guys, if you're finding these solutions helpful and want to see more of my physics content like this, okay, so don't forget to give this video a thumbs up and hit the subscribe button below. Okay, so your support, guys, means the world to us and help us to keep bringing you more challenging physics problems to solve together. Okay, so guys, your support is very much more important because it motivates us to keep going and to keep solving more problems for you, because I understand that some people are upgrading, they do not have tutors that they can afford, so this content is much more preferable to them, and also for the grade 12s that are finding challenge in physical science. Okay, and also guys, don't forget that there is I'm gonna leave the link of this paper in the description below, so you can download this paper for yourself and then you can do the practice questions. You can download this question paper and then you can do this question with me if you didn't have much more time to do it on your own as I'm doing it now. All right, so basically now what we're gonna do is that you're gonna take this what? We're gonna take this 28 minus 28,387 over the equal sign. All right, so it's gonna be t is gonna be equals to 8 plus 28 comma 387. Right, so we're gonna have what? The tensional force now we've calculated is gonna be what? It's gonna be 36 comma 387. All right, so let's go back to our calculator to confirm that I'm doing the correct thingy. I'm not making up these answers. All right, it's gonna be what? It's gonna be 8 plus what? Plus 28 comma 387, which is what? Which is 36,387, guys. So this is what? Is this a vector or what? Or scalar? These are vectors, guys. Ne? So you need to what? You need to show the direction, because a vector has a what? Has a magnitude and also shows the direction. All right, so newtons up the slope. All right, so you're done with the what? With the 2.3 question. So let me just bring this down, guys. Let me just bring this down. All right, so this is what we're done with 2.4. We're done with 2.3.1. Right, so now let's do question what? Let's do question 2.3.2. It's 2.3.2 basically. All right, so what does 2.3.2 require for us to do? So 2.3.2 requires us for to what? To find the force F, which means the applied force. Right, so for you to be able to tackle this question again, you need to choose a body that you need to solve for. Right, since you know that the applied force is being applied on what? On object B. Right, so now we're gonna focus on object B. Guys. Right, so now as I've said before, when you're solving these questions that an object is in a plane, so the first thing you do is to what? Is to solve for the parallel vector of the gravitational force. So again, you have to solve for what? Sorry, you have to solve for the parallel vector of what? Of object B. It's equals to mb what? It's mg sine theta. Right, so the mass is what? The mass of the object, it's 9, and then the what? The gravitational force is what? It's universal, which is 9,8, and then it's applied at an angle of sine 35 degrees. Right, so now our answer is what? Let's go back to our calculator to assist us. So it's gonna be what? It's gonna be 9 multiplied by 9,81. Right, So then comma 81 is going to be 88,29, right? 88,29 sine 35 degrees, right? So guys, yeah, I'm your go-to tutor because I'm not only I'm knowledgeable about this content, I'm also what undergrad, which is fighting to graduate, guys, because yeah, I understand that some people might be not be much more recommendable, because yeah, but anyway, so it's gonna be what it's gonna be 88,29, which is gonna say answer multiplied by what, by sine of 35 degrees, which is gonna be what, which is gonna be 50,664 degrees, which is gonna be what, 60,54 what, 54 newtons, 64 basically, not 54. It's 50,64 newtons. It's 60,64 newtons, guys. 60,64 newtons. Right. So we've actually solved for what? We solved for the parallel gravitational force, right? We are solving the parallel gravitational force because this object is acting in the plane, right? This object being pulled in the plane, the parallel gravitational force is going to be acting against the applied force, which is the direction of motion. So it's going to act as friction, basically, to be quite frankly with you. So now we need to check the formula. So it says F net is equals to what? It's equals to MA, right? With that being said, now we need to look at the components that are being applied on object B, guys. We need to look at components that are being applied on object B, right? So yeah, guys, please, if you have any questions about this type of content, you can just comment down below in the description, in the comment box. Description. Yeah, you can comment down below, guys, and I'll answer you as soon as possible, or as soon as I get time. So it says that the forces that are acting on this object, what is it now? On this object is going to be the what? It's going to be the applied force, going to be F applied, right? And then it's going to be the what? Minus frictional force, right? And then minus tensional force is equals to MA, right? So you might be asking yourself, why am I saying that? Why am I subtracting tensional force from this equation? So basically, the reason why I'm doing that is because if you look at the plane, if you look at object B has this applied force, which is this one that is pulling the object upwards, and also there's this tensional force that we calculated earlier on, right? So this tensional force is not acting in the direction of motion. Basically, it's dragging object B downwards, right? Object B is being pulled downwards by what? By this tensional force, and this tensional force carries what? It carries this object. So that's why I'm saying that tensional force is being subtracted from the applied force, right? And you know, most friction is always against the direction of motion. Nothing new in this, nothing new here. Yeah. So what is gonna be F applied minus what? So the frictional force is what? The frictional force is 13 newtons. So this is the 13 newtons. So it's gonna be what? Minus 13,23, right? And then minus what? And then the tensional force we calculated earlier on, it's 60,64 newtons, right? Which is equals to the mass of the object, it's 9 kg, and the acceleration, it's 2 meters per second squared, right? So the F applied will be what? You can take out your calculator and yeah, follow me in this question on these simple calculations. So it's gonna be what? It's gonna be minus 13 is gonna be minus 13,23 minus 60,64, right? Is equals to 9 times 2, it's gonna be 18, and then it's gonna be FA minus what? It's gonna be minus 36, minus 36,387,387 is equals to what? It's equals to 18, right? So now what needs to happen is that these two digits, 30 minus 36,38, it needs to jump the equal sign, eh? You know, most it's maths. Hence, I don't understand how come that people that are doing applied physics are doing it with maths literacy. Guys, you are bold, yo. I would never be able to do that. So it's gonna be FA is equals to what? Is equals to 18 plus what? Plus 36,387, right? Which is FA is equals to what? FA is equals to 118, what? 118.26 newtons, 26 newtons, right? And also guys, you know that this is a vector, the vector quantity, right? So all vector quantities have what? They have both magnitude and direction. So we're just gonna say therefore the applied force, the applied I'm just gonna say the applied force is 118.26 newtons up the slope. Oh, maybe you can say the applied force, just gonna say applied force is what? The applied force is 118.26 newtons up the slope. Or if you don't say up the slope, you can say you can say it's applied force is 118.26 newtons in the original direction of motion, because this thing is still going in the original direction of motion. Nothing has changed yet. You understand? So yeah, let's do our 2.4. Let's take a 2.4. So 2.4 says 2.4.1, right? So 2.4.1 asks us the angle that the plane makes with the horizontal is now decreased, right? So now the angle now is being decreased. It's now it asks how will this change the kinetic frictional force acting on block A, right? Choose from decrease, increase, or remain the same. So the frictional force now, since the angle is being decreased, the frictional force is gonna what? It's gonna decrease, guys, right? It's gonna decrease, right? Why am I saying it's gonna decrease? Because I'm saying the frictional force is gonna decrease because when you decrease the angle, of the weight of the plane, what's gonna happen is that the FG parallel, when you multiply the what, you're gonna multiply the mg, right? You're gonna first multiply m and g, right? Which is mass and gravitational force, and then sine of the angle, right? So if the angle decreases, what happens? Is that also the FG parallel will decrease, right? So both, also the FG parallel, guys, will decrease in the case, right? Which means that in total the frictional force will decrease because the mg parallel and the frictional force are working in union against the what? Against the direction of motion. They are both acting against the direction of motion, guys, right? So you can just manipulate this with yourself. Maybe put 20 here instead of what? In this theta instead of 35 degrees, and you can see for yourself, right? And then it's gonna be what? Let's do 2.4.2. 2.4.2, right? 2.4.2 says explain why. You can just say what I've just discussed now. We're gonna say that it will decrease it will decrease because the magnitude because the magnitude of the parallel gravitational force, magnitude of the parallel gravitational force, right? Gravitational force will what? Will decrease. Gravitational force that is acting against that is acting against it will decrease because the magnitude of the parallel gravitational force that is acting against what? Against the direction of motion, against the of motion will what? Against the direction of motion will decrease. Right? So basically, guys, this is it. Because now as the angle decreases, both the FG parallel, which is the parallel magnitude of the gravitational force, will decrease, right? And also, as I've said before, that the gravitational magnitude that is parallel to the plane is working in conjunction with what? With frictional force, pulling the object downwards, right? So now, if we decrease the angle, meaning that the magnitude will decrease, meaning that also the frictional force will decrease. Because if you look at these questions that we're doing here, I was saying what? I was saying frictional force frictional force minus what? Minus frictional force minus what? Minus t, because these are two are working together against what? Against the direction of motion, right? So yeah, guys, this is it for this video. And also, if you have any friends that is struggling with maths, physics, or life sciences, you can also share this link with them, because I understand it might be frustrating to suffer alone and have no one else to help you on your side. And I understand tutoring is expensive. You cannot be tutoring nowadays is 200 rand per hour, right? And this is a logic subject, and which means the prices are even much higher, right? So yeah, guys, this is Science Services Circle. If you have any other questions, you can put them in the description below. Not in the description. Why am I keep saying that? In the comment section below, guys, and I'll answer you as soon as possible. Yeah. As for me, and I'm out today. I'm gonna see you on our next what? In our next tutorial.